To start us off, we're looking at my laptop, and I've brought up section 5.4, applications involving quadratic equations. And we're looking at this first example. During the first part of a trip, a canoeist travels 18 miles at a certain speed. The canoeist travels 4 miles on the second part of the trip at a speed of 5 miles per hour slower. The total time of the trip is 3 hours. What was the speed on each part of the trip? And I've put in the answers, and I've got them correct because I've worked this out. But now what I want to do is show you the strategy for getting these answers. And this will work pretty much in any kind of problem that's like this. So what I've laid out here, you can see why I'm not an artist. This is someone in a canoe that's going to do a certain distance, and I've made one of the distances 18 miles from the problem, and the other distance 4 miles. And at the 18 miles, he did a certain rate. We don't know that rate. And at the 4 miles, he did that rate, but 5 miles an hour less. So in a sense, this is that portion, the 18-mile portion, and this is the 4 mile. Now the total trip took 3 hours. So this is the information they've given us in the problem. And what we're wondering about is, how do we figure it out? Well, again, this recipe is going to apply for many things, so it's going to be very useful. Now, our basic formula is the distance formula, in which we know distance equals rate times time. But we know distance and rate. Distance and rate. What is distance and rate? Well, it's time. Time is distance divided by r. And we got that by just dividing both sides over here by r. The r's cancel out, and that gives us time. So this is the first amount of time plus the second amount of time, and that's going to equal the total time. So what is our equation then? And again, you're looking at a recipe. If you get something similar, it's done in a similar way. It's going to be 18 over r plus 4 over r minus 5 equals 3. So now we go back to a previous module where we had equations with fractions in it. And the rule is, how do we get rid of the fractions? Well, we said we multiply each term by the lowest common denominator, which in this case is r times r minus 5. Now I could put it out and put brackets, or I could put it by each one. So there's my common denominator. And now what I want to do is get rid of my fractions by multiplying each term by my lowest common denominator. So here the r's cancel out. Here the r minus 5 cancels out. And here nothing cancels out. So I then rewrite my equation, getting rid of parentheses as needed. This is going to be 18r minus 90. 18 times r, 18r, a negative 5 times 18. And here this is just r times 4, 4r, equals, now this is 3r times r. This gives you 3r squared. And then 3r times a negative 5, a negative 15r. So again, much simpler without fractions. Now we collect like terms. Here we're going to get 22r minus 90 equals 3r squared minus 15r. Now this is a quadratic equation, so we're going to solve it by putting it in standard form. So since this is positive, I'll move these over. This goes to this side as a negative r, 22r. So this is going to be a negative 37r. And this comes over as a positive 90. And that all equals 0. Now as we look at this, you might say, oh, that's kind of daunting. I can't factor out a 3 from any of these. That would make the numbers a little smaller. But I played around with this, and this actually factors. So 3r, r, this will be a 9 times 10 here. And in order to get a positive, both of these need to be negative. Now, when we equate each of our factors to 0, this comes out as r equals a positive 10 thirds, and this comes out to r equals 9. Now, this can be reduced to 3 1/3 in a sense, and this is 9. Now, is this a valid answer here? And the thing is, if you put it in there, you end up with a negative rate. So this is an extraneous root, and this is the answer. So if I put 18 divided by 9, I get 2 over here. And if I subtract 5 from this, this is going to be 4. 4 divided by 4 is 1. So 4 plus 1 equals 3. So the 9 checks, and when I put it into the lab, it worked. So in summary, we made a diagram after reading the problem carefully. We decided on the formula of distance, where we knew the total time, and if we solve for time, time is distance divided by rate. Distance divided by rate. Distance divided by rate, and if we added these two times together, it equals 3 hours. Now, you might say here, you probably couldn't factor this. Well, you would then put this equation into the quadratic formula, where A is this, B is this, and C is this. Remember, factoring is the easy way. If it does factor, you might try that. For many of these, that will be a solution. Okay, well, good luck on these.